Let's start with some reminders about the coordinate plane. The coordinate plane, also known as the Cartesian coordinate plane, named after the French mathematician René Descartes, looks like this. We have two axes, the x-axis, which is the horizontal axis, and the y-axis, which is the vertical axis. It divides the coordinate plane into four sections called quadrants. The quadrants are as follows: 1, 2, 3, and 4, and the quadrants are always written in Roman numerals. The thing that I want you to remember about the ordered pairs that lie in these quadrants is that quadrant 1 has positive x and positive y. Quadrant 2 has negative x but positive y. Quadrant 3 has both negative x and y. And quadrant 4, the x values are positive, but the y values are negative. This will become very important when we study trigonometry in the not-too-distant future. Let's talk about graphing regions in the coordinate plane. It's probably not something you're quite used to. You're normally used to graphing lines, parabolas, things like that. The problems in example 1 are written in something called set builder notation. I'm not a big fan of requiring students to write answers in set builder notation. However, if you see it, I want you to understand it. Basically, what problem A says is, for anything graphed in the coordinate plane, that's why they give you the little ordered pair xy, they want you to show the graph of x is greater than or equal to 0. Basically, that means instead of graphing it on a number line, you graph it on the coordinate plane. Well, the graph of x greater than or equal to 0 is going to be a horizontal line through 0. And not only is it going to be horizontal because it has an x and no y, but it's going to be a solid line because of the greater than or equal to. If it had just been the greater than symbol, it would be a dashed line. Oops. So it's going to be a solid vertical line through 0 on the x-axis. And because it's an inequality, inequalities get shaded when you graph them. This gets shaded to the right because it wants to know where are the x values greater or equal to 0. Alright, so now I'm going to get rid of this and let's go to problem B. For a graph in the xy coordinate plane, what is the graph of y equals 1? Alright, so in the coordinate plane, that's a line. Any equation or inequality that starts with a y but has no x is a horizontal line. So where anything with an x is always vertical, anything with a y is always horizontal. And then if you have an equation or an inequality with both x and y, it's usually some sort of diagonal line. This is going to be a horizontal line through y, through 1 on the y-axis. And that's all it looks like. Nothing extravagant. The last one is the one we're going to have to do a little more work for. So let's go back to the fact that we just talked about absolute value inequalities in section 1.7. So there are two inequalities here. One of them is y is less than 1. And the other one is y is greater than negative 1. And the question is it and or or? Is it a union or an intersection? So either I'm going to graph both of these, and they're both going to be horizontal, just like the previous problem, and the shadings either overlap between them, in which case it's an and, or the shadings don't overlap at all, in which case it's an or. So y is less than 1 is going to be a dashed horizontal line through 1, and less than means shade below. Y greater than negative 1 is going to be a dashed line through negative 1, and greater than means shade above. Well, because the shadings are going at each other, let's get rid of this real fast. That means that the solution is where they overlap, which is in here, and it must be an and statement. In an earlier video, we talked about finding the distance between 2 points on a number line, and the distance between 2 points on a number line was easily found by taking the absolute value of the difference between the points. And it really didn't matter if you do b minus a or a minus b, because you're taking the absolute value of the difference no matter what. On the coordinate plane, the distance formula between points A and B is a little bit different. And it has to do with finding the hypotenuse in a right triangle using the Pythagorean theorem. So if you remember a squared plus b squared equals c squared, the distance from A to, we'll call this point C, because that's just a horizontal line, it's just going to be the difference. Ooh, I wrote this wrong. Let's fix this. It's going to be x2, y1. All right, it's going to be the difference between the x values because the horizontal line has no change in the y values. So this is just going to be x2 minus x1. And really it's the absolute value because it doesn't matter what order you subtract it in. The distance of the vertical blue line is going to be the change in the y values because the graph of that line doesn't go left or right, so the x values don't change. So it's going to be the absolute value of y2 minus y1. So then what's this going to be? Well, using the Pythagorean theorem, we find out that if I just call this, we'll call this C, we'll call this A, we'll call this B. So A squared plus b squared is going to equal c squared. And then you take the square root. And c is our distance from A to B. And we just derived the formula for the distance between 2 points on any coordinate plane. This is the formula for the distance. Let's apply the distance formula. Which of the points, P at 1, negative 2, or Q at 8, 9, is closer to the point A at 5, 3? Well, in order to figure out which one's closer, we're going to use the distance formula to find out the distance between the two. So, let's find the distance from P to A. The way the distance formula works is we want to take the square root of the second x minus the first x squared plus the second y minus the first y squared. Watch out for your double negatives. So, 4 squared plus 5 squared, 16 plus 25, which is the square root of 41. Now let's find the distance between Q and A. So, second x minus the first x squared plus second y minus the first y squared. That's going to be the square root of negative 3 squared plus the square, or sorry, the minus plus negative 6 squared. Since we're squaring negatives, they're going to become positives, so 9 plus 36, which is 45. So which one's the smaller number? Well, the square root of 41 is the smaller number, therefore P must be closer to A. The midpoint formula was a formula for finding the ordered pair that was exactly halfway between two other points on a line. So if I give you this picture where M is the midpoint between A and B, and I draw myself two little right triangles so that AM is the hypotenuse of one right triangle and MB is the hypotenuse of another, we know that the distance from A to M and the distance from M to B have to be congruent because otherwise m's not the midpoint. So we're going to call point A x1, y1, point B is x2, y2, so m must just be at some point xy. So the distance here must be x minus x1, and the distance here must be x2 minus x. Well, if these two triangles' hypotenuse are the same, I'm telling you that the triangles are congruent, and therefore the bases of both triangles must be congruent. So x minus x1 must equal x2 minus x. Well, if I add x to both sides, I get 2x minus x1 is equal to x2. And then I'm going to add the x1 to both sides, and I'm going to get 2x is equal to x2 plus x1. So x is going to equal x2 plus x1 divided by 2. In other words, the x-coordinate of the midpoint is the average of the x values of points A and B. Well, guess what? Y is going to work exactly the same way. I could go back up here and I could call this one y minus y1, and I could call this one y2 minus y, set them equal to each other and do the exact same math, but I'm going to end up with the same answer. So it turns out, in order to find the midpoint, you just find the average of the x's and you find the average of the y's. And guess what? Even though it says x2 plus x1, it doesn't matter what order you do it in because you're adding them. So let's apply the midpoint formula. Show that a quadrilateral with vertices P12, Q44, R59, and S27 is a parallelogram by proving that its two diagonals bisect each other. Alright, in other words, if I draw myself a coordinate plane here, and I'm making quadrant 1 bigger than everything else because most of the points are in quadrant 1. Point P was at 1, 2. There's P. Q was at 4, 4. There's Q. R was at 5, 9. And S was at 2, 7. There's S. So there's my not so nicely drawn picture. Apologize. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Looks like I kind of did it right, but remember in geometry, pictures not drawn to scale. All right. So there's one diagonal, and there's the other diagonal. If those two diagonals bisect each other, the midpoint of each diagonal will be the same. So why don't we find the midpoint of SQ, and we'll find the midpoint of R and P. So let's start with S and Q. The midpoint of S and Q, you're going to add the x's, divide by 2, add the y's, divide by 2. Well, 6 divided by 2 is 3. And then I get 11 over 2. So the midpoint of S and Q is 3 and 11 halves. For R and P, I'm going to get 5 plus 1 over 2, and I'm going to get 9 plus 2 over 2, which just so happens to be 3 and 11 halves. And now I've just proven that it's a parallelogram because the diagonals bisect each other. Remember in geometry we learned that a parallelogram, the opposite sides are parallel, they're congruent, and their diagonals bisect each other. I'm going to gloss over the last part of this video because the problems we're about to talk about are ones that I expect that you can plug into a graphing calculator and look at the graph on the screen and use the table function in order to find the ordered pairs. But let's say your graphing calculator's batteries died or somebody stole it from you. How are you going to graph 2x minus y equals 3? Well, you're going to solve it for y, to start the problem off. So I'm going to subtract the 2x, and then I'm going to divide everything by -1. So this is what I'm going to graph. When you go make a table, one of the most direct ways to do it is to pick some x values. And I usually use these x values, and then I plug them into the equation to find y. So when I plug in -3, I get -9. When I plug in -2, I get -7. When I plug in -1, I get -5, -3, -1, 1, and 3. And then you would graph those on a coordinate plane. So let's see, -3, -9 would be down here, and then it would kind of do, let's see, -1, -5, 0, -3, 1, -1 would be there. Let's try that real fast. 2, 1, 3, 3. It would look something like that. Instead of making a table, which works, you can also just use your graphing calculator function as long as you type this in correctly. You would hit graph, and it should show you something that looks like this. And then if you go to second graph, it'll tell you all the ordered pairs that lie on the curve. And then you can use the up and down arrows to find other ordered pairs that lie on that parabola. But I would hope that you would know before you ever plugged it into the calculator that this should be a parabola because it's a quadratic equation. In order to graph an absolute value graph on the graphing calculator, when you go to y equals, you would press the math button and arrow 1 to the right to number, and number 1 should say this. And then hit enter, and if you have a newer graphing calculator, then this pops up. If you have an older version of the graphing calculator, this will pop up, and either way you just type in x. When you hit graph, you should see this graph. Let's talk about for a minute why you get this V-shaped graph. Well, let's think about absolute value equations for a second. When we talked about absolute value, we said, well, one of the equations is going to be y equals x. Well, the graph of y equals x is this line here that goes up from left to right, and it passes through the origin. The other equation is going to be the graph of y equals -x. Well, the graph of y equals -x is this line that goes down from left to right but passes through the origin. But why aren't these parts of each of those graphs on the final graph of an absolute value function? Well, what does absolute value mean? It means that it becomes positive. All the y values have to be positive, and all the numbers down here would have negative y values. So in essence, those go away. And you're left with just the top half of these two linear equations, in which case it makes a V shape.